because I'm trying to upload the slides. Okay. Hello again. Let's start today's session. Uh, can anyone tell me what was the last slide we've discussed? Let me bring some slides and then we can talk. Okay. Have we discussed non-stop forwarding or not? This one. Non-stop forwarding. Can anyone tell? Or this one or this one? Guys, are you there? Are you there? Can you hear me? There's 19 people at in the class and nobody remembers. I don't know why this we have this problem in this class. Students are reluctant to participate. I don't know. Can anyone tell me what was the slide? It doesn't matter. I start removal from service. Okay, software rejuvenation or removal from service. In this activity, we put the system. Put the system in out of service state and temporarily. You know, for example, in each 1 hour, we can do this software rejuvenation technique. We can place comment or whole system out of service for a small period of time to prevent problem like memory leak. We call them latent faults. Okay, things like memory leakage or when for example we demanded a resource from operating system and we've done with that resource, but we haven't released it. Okay, we haven't released that resource, so now that resource is not being used by us and not by any other software or code in the system. So this is what we call trash. Okay, trash. This is trash. Trash is something we don't use, and we have access to that, and also we don't let other people to use it. Okay, this is trash in the concept of memory management. Trash is a part of memory, for example, that we don't use it because we lost its path, and also we haven't released that part memory, that sector, so nobody can eat anymore. So for example, we have 4 gigabytes of memory, and now 1 gigabyte of this memory is consumed by a program, and after that program done its job with it haven't released that part of memory. So it doesn't want to use that part of memory. Also, as it has not returned this memory block to the OS, no other program can use it anymore. So this is trash. Okay, and these latent faults, such as this memory leak I told you about, trash or memory leak, can escalate to a severe situation like failure. You may already have seen some programs that tell you, okay, I don't have enough memory, I cannot run, or I should exit now because there are no enough slots in the memory. Okay, this is what has happened because of because of memory leakage usually. So when we put our software components out of service, in and out of service, uh, we can make sure that those memory leakage uh, may be resolved, and the program can start with fresh state. Okay, uh, you may already experience that. You may run a program, and that program becomes slower and slower and slower, and then you quit that program and restart it, and then see that program works faster. This is because this program has some memory leakage fault, and after some operations, it may experience slowdown in the performance because um, there are not enough memory slots available for it, and it needs some extra uh, activities such as using virtual memory, which decreases the performance. And we can say that, oh, this program is not as fast as it used to be. Okay. Any question? Any question? Okay. Thank you, dear Muhammad Salim. Thank you, dear Ali Adel, for your help. So, uh, about transactions, we use transactions massively in database management systems. Um, but transactions can be used in different areas. But mostly we use them in, I know that mostly you've seen transactions in database systems, but we can use them in component based designs in, for example, Java transaction services are a very famous transaction management framework. And also we have this Complus from Microsoft that supports transactions on the components. So I told you, I know that you know about the transactions, what the transactions actually are. Uh, Here, I want to emphasize on this important thing here. Um, okay, using transaction helps us to race condition. I told in the previous session that you should study about race conditions, and it may cause erroneous outputs, and we want to avoid race conditions using tactics like two-phase commit or 2PC protocol, which is a transaction-based uh, tactic, will help us to prevent race conditions. Okay, so, when we use transactions, we can say that, okay, we don't have the problem of race condition. So it's a preventive method. It's a preventive method. Using transactions will lead to prevention of race condition. So it's tactic. Preventive tactic. Okay. Transactions are very effective in controlling bad conditions, bad situations. It also helps us to have maximum concurrency by preserving consistency. It's so important that we can have good degree of concurrency uh, with guarantee for consistency, serializability. This is so important. But it's very effective tools. You will learn about transactions. I know that you know about transactions, but you will learn about them in advanced database advanced database course. Okay. Do you have this course currently? Do you have a course uh, in your current studies? Do you have this course, advanced database, or not? In last term or this term, have you had this course? No. Okay. No. Okay. Maybe next term. Maybe next term. I teach two groups of advanced database for international students, inshallah. Okay. This is transactions, and transactions will prevent some bad situations like race conditions. Okay, and you can use them to help you implement concurrency and consistency very effectively. Yes, dear Hussein. In college, you have a course named database, and in graduate studies, you have another course called advanced database. Okay, in advanced database, you usually focus on more advanced topics, and one of things that usually are taught in this course is transactions and their implications. So let's proceed to the next tactic. Yes, dear Muhammad Salim. I hope that in the next term I have enough time to teach two groups of advanced database, or maybe more if I have enough time. So we have another tactic which is called predictive model. Predictive model. In predictive and prediction and predict means to forecast. Okay, to forecast. For example, when I sit here and I look at the sky and I say, okay, I can forecast that we have a rainy day. We may have rainy day. Okay, it's for example 18 a.m. 8 a.m. And I may predict something that may happen in 3 or 4 hours later. I predict according to sky, according to my knowledge about the cloud movement. Okay, clouds movements. I can see the sky and say, okay, I think it's going to be a rainy day. This is a prediction, and we can have these predictive models to monitor the state of health of a process or a component to ensure the system is operating within nominal parameters. Let's see this one. This example is very good. For example, when you monitor a web server, and you see the establishment rate is beyond the specified range. You say, okay, this server is to have some problem, or maybe it crash in a matter of minutes or hours. Okay, currently the server is perfectly working. Okay, but you check the session establishment rate. For example, the requests call the server. You can see that if we continue this session establishment rate, the server will fail in, for example, 10 minutes or 30 minutes, because I can see that the memory is going to fill session data regarding the users. And after, for example, 30 minutes, I can say that the server will be crashed. So we can put some constraints on the new sessions, and we can drop some sessions. For example, currently we have 10 sessions in each second, and then I can drop 3 sessions in each second. For example, I have 10 session establishments, session requests each second, and then I can decrease it to 7 requests, drop 3 requests, and this will prevent the server crash in the near future. Okay, so I monitor a state of health of a process, which in this case it's the server, and if there should be any corrective acts, I will do them to prevent system failure. Okay, so we're talking about future faults. Please, everyone, please read this important slide. Let me tell you, many of my graduate students, they have tested me. Many of them are currently working on these predictive models. You can see their papers online. You can study their works. They use predictive models. For example, they use deep learning, neural networks, fuzzy logic to create some kind of model to predict the future and prevent some disaster or crashes. Okay, so please, everyone, read this important slide, and if you have question, I'll answer you. Okay, I've been disconnected. Now I'm connected. Okay, I cannot understand your question, dear Ali Adel. Can you write it in English? Dear Ali Adel, can you write your question in English, because I can understand your question. Okay. So, any question? Any question here? Is this property used in artificial intelligence? You know, we use artificial intelligence to predict that something bad is going to happen. Okay, we use it to predict something bad is happening. Okay, for example, we may use tools like, let me write it here, neural networks. Neural networks to create some or different tools, regression, linear regression, or even logistic regressions. Okay, we may use different tools to create this predictive model. Okay, to create this predictive model to predict that something bad is going to happen in the future. Okay, dear Mohammed said, oh, okay, it seems that officer. Let's is there any question? Is there any question here? Okay, let's continue. Exception prevention. Exception prevention. You know, I told you before about exception detection. Yes, exception detection. I told you about exception detection. I told you about try, catch, block, if you remember. try catch block. I even show an example. Okay, um, that was exception detection. But now, talking about exception prevention, what is the difference? In detection, we will understand, we will detect, we will be aware of an exception after it happens. So we put some dangerous code, some lines of code that we think that this block may create some kind of exceptions. Okay, we put it in the try catch block, and if that exception happens, we catch that exception. Okay, this is exception detection and exception handling. But now we are talking about exception prevention. We want to prevent. We don't want to let some exception to happen. Okay, so we try to prevent exceptions. This is our goal in exception prevention methods. For example, when we use, you all know pointers. Okay, pointers. You all know pointers. We know that pointers, for example, we use pointers in C++ language. And we know that pointers are very dangerous. Using pointers may cause problems like dangling reference. Dangling reference. And also they may cause garbage, or some people may say trash. Okay. Using pointers may cause dangling reference or garbage. Okay, garbage or trash. Some programming language like C and C++ let user, and Delphi, if you know Delphi, Delphi also lets you to create pointers. These programming languages let the program to use pointers, and pointers are very effective tool for memory management. But if you don't pay specific attention when using pointers, you may create some very dangerous code blocks. You may cause dangling reference in the system. Dangling references are so dangerous in the system. Okay, so these are exceptions. So this one is exception. This one will create exception in the system. So if we use smart pointers instead of pointers, if we use smart pointers, then we are sure that dangling reference will not be created. So if you use smart pointers instead of using pointers, then you are 100% sure that dangling references will not happen. Excuse me, garbage will not happen. Also, dangling references can be prevented. The point here is we can use some methods, some tactics to prevent exceptions. For example, using pointers prevent some exceptions regarding the pointers, like garbage and some kinds of dangling reference problems. Okay. So this is a homework for you. What is what is dangling reference, and what is garbage. Okay, you should study these two things, dangling reference and garbage. But here, as a recap, I can tell you that using emission prevention tactics like smart pointers help you to eliminate the probability of causing an exception or creating an exception. So by using these tactics, we can be 100% sure that some specific kinds of exceptions may not occur in the system. Okay, any question? Any questions here? Okay, let's go to the next slide. This is the last tactique we want to learn. Dear Hossein, do you have any question? I see that you're typing. Okay, let's go back. What is your question? No. Who's that? No. You can implement arrays with pointers. For example, you store the starting point of an array. You know, arrays are a sequence of locations in memory, and if you store the address of the first element, and also if you know the type of array, for example, each array member is 6 bits twice integer, normal integer, 16-bit integer, then you can calculate. Yes, you can implement arrays with pointers, but it's not the point here. I'm telling you, pointers use okay, and you cannot evade the use, okay? Because everything in C++ usually lead to some kind of pointers. For example, you want to create objects, you have to work with pointers. You want to send a parameter with reference, you need to send the reference of that parameter. Okay. I'm waiting for the. Okay. So you, in some settings, you may use pointers, and you don't have even an array. For example, you want to work with objects, okay, or you want to store something in heap memory. Saving resources. What do you mean by saving resources? Dear Muhammad Salim, where have you seen that? Let me know. Where have you seen this phrase, saving resources? I don't understand your question. Do you have any question about some specific programming language? Saving resources generally means using less resources. For example, you may need to pack arrays or objects to or big matrices to store minimal amount of memory. Okay, but I don't understand your question. Can you write a full sentence, because your writing is in 3 parts? Can you write your question in one coherent question so I can understand it better? And if you have any question from any specific programming language, please name it. For example, say in C++ that, in Pascal that, in Java that. Guys, you know, some programming language don't let you to use pointers. For example, when you use Java, you can't use pointers. Java eliminated pointers thoroughly. Memory management is automatic. So in Java, you don't have the problem with pointers. Java use this preventive fault technique. Okay, uh, in Java you don't have pointers. Okay, done. Pointers are eliminated from Java. Uh, so also in C plus, in C sharp and Visual Basic, okay, many programming language, modern programming language, don't let you use pointers because they are so tricky, they're so dangerous, and you can do anything you usually do with pointers without pointers if the language has the facilities regarding to memory management, automatic memory management. Java was the first programming language that removed the pointers thoroughly. First full and comprehensive programming language. Also, you in programming language like Commodore Basic or GW Basic or Quick Basic, you don't have pointers. Guys, do you know old computers? For example, are you familiar with computers like Commodore or Amiga? These kind of computers, do you know them? For example, Commodore 64. Guys, have you heard anything about, for example, Commodore 64? It's an old computer. Nobody? So strange. Okay, it has a programming language named Basic, Quick Basic. You know, I started learning computers when I was 6 with a Commodore 64. Uh, we have this Commodore 64 in our house for games, but I started learning basic programming language when I was 6 with this Commodore 64, and it has a basic language. So that programming language was so simple, and it doesn't let you to use pointers and many modern uh, modern facilities. Okay, let's go to the next slide. Increase competence set. Increase competence set. Okay, everyone, please read this slide quickly. Quick, please read it. Okay, you know, in this tactic, we're talking about some interesting point here. You say that you want to design something that when it crosses some problem, it try to come up with a better solution or another solution and try it again and again and again. For example, when you want to connect to internet, your computer tries to connect through line. Okay, for example, your landline, your LAN network, and if it fails, it may try to use your Wi-Fi, and if it fails, it may suggest you, do you have any hotspot available? For example, I connect to your phone, and through your phone I connect to the internet. You know, it tries different ways to connect you to the internet. Instead of responding, okay, there is no connection, done, finished. No, it tries to come up with different ways to overcome this problem. It tries to suggest you, or it tries to go through different paths to create to connect you to the internet. Okay, this is an increased competence set. Okay, so we can say that designing a component to handle more cases of faults, specifically as part of its normal operation. For example, you may say some persons that okay, go and get water. Go and get water. He went to the kitchen and checked the tap, and uh, he sees that there's no water in the tap, and then he can return to you and he can say, okay, there's no water, finished. But with an increased competence set, it can do such thing. He can check the tap water, and then if he sees that there's no tap water, he can check refrigerator. And if there's no water in the refrigerator, he can go outside of the house and goes to, for example, a neighbor, and call the neighbor and knock their door and say, hello, do you have water? And then if that neighbor answers no, for example, he can go to the next neighbor, next neighbor, next neighbor. Even he can go to the shop and buy some bottled water. Okay, this is an increased competence set. If that person sees a problem, if he experiences a problem, he try another way. Okay, for example, when you try to print something on your printer and the printer is not connected, the program may come up with another idea. It can says, okay, do you want to save the output as a PDF file so you can print it later, or do you want me to wait for you to attach the printer cable to let you print? Okay, this is an increased competence set. Okay, do you have any question? Please now read this slide with more attention. Okay. Dear Muhammad Salim, we usually have fixed set that we may try them, and then we come up with a solution, or maybe we may say, okay, we cannot solve this problem. There's continuous search for a solution. In most cases are not feasible because it's lots of time, and it has its own design complexities. Okay, it has its own complexities. So in most cases, I can say no. We have a fixed set of solutions that we try them. If the first one fails, we may proceed to the next. If next one fails, we proceed to third, and that's all. We don't want to search in an unlimited way for an answer, for a solution. Because, for example, when you don't have internet on your wired connection, you may try Wi-Fi, and next you may try hotspot, or you may try the cellular network. You don't have any other options here. Okay, usually there are 3 or 4 options maximum. Thank you, dear Muhammad Salim. Okay, I think we are at the end of this series. Yes. Sorry, it was my small daughter. Sorry for that. Okay, we are at the end of this series of slides. Let me upload the next session for you. Okay, I think we need a break, and after the break, we can continue today's session. The next thing we want to talk about is testability. Okay? Okay, let's continue. At the remainder of the section, this session, we want to talk about testability. But first, let me ask you Do we have any groups who wants to present? Do we have any groups who want to present? Okay, it seems no groups are ready. Oh, 4 students. So, okay, so uh, it's a lot. So let me check the time. Okay, so who's going to present first? Because we don't have enough time for 4 students. Who's going to present first? Okay, dear Ghasaq Majid, please test your microphone. Yes, of course. Of course, dear Alia Adel, I will open share for you. But first, I need to discuss the basic definition of testability, and then we will have the presentations. And I think we don't have enough time for 4 presentations, but we'll try. Okay, guys, what is testability? Hello, hello, dear Ghasaq Majid. Can you hear us?
السلام عليكم دكتور.
Salam alaikum. Okay, it seems your microphone is working. So wait for just a few seconds, and I will transfer the presentation privilege to Ali Adel, uh, and you can start your presentation afterwards. So testability. Testability refers to the ease with which software can be made to demonstrate its fault through testing. Okay? It's basically it means that how well you design the system, the software, that when you want to test something, those faults and those erroneous design can be found. Okay? So if you test your software, then those faults can be identified. Okay, this is testability. So we can say that this is the probability that if we know that our software has some problem, some fault, then you can find it through the next test cycle. Okay, so we need our software to be testable. We don't want to talk about testing and how we can perform testing, but instead, I'm telling you that uh, if your software has some fault in it, how is how are these faults are going to be identified? How hard it is to find these faults? Okay, so for example, if you design the engine of your car in a fully closed box, then when there's fault, no one can find it, or it needs lots of effort to find it. But when you design your car in a modular way, as it's now, as you can see in today's modern cars, finding the fault, finding the problem is a lot easier. So it's more testable. So when you design your car in a black box, in a fully closed box, finding errors in that box is so hard because you cannot see through that box. Everything is hidden inside, and maybe it's everything is coupled with each other, or coupled with each other. It's so hard to find the fault. But when you design your car engine with different devices and different components, then you can